Okay, so now that we have, so this is a lecture 11.3, where we're going to continue with our hard sphere gas, right? But now we're going to relate it to our demo. So our hard sphere gas as applied to throttling, let's say. Okay, so remember in our throttling process, we said it was constant enthalpy, right? So that was our key features, that we were constant enthalpy, or we could have written it as the enthalpy, the molar enthalpy, which is nice because we were going to have these B's, which are molar, like molar volumes, right? And H was U plus P times V, where this is a volume, a molar volume. And this is the internal energy per mole and the enthalpy per mole. Okay, so throttling is an isenthalpic process, but now instead of applying the ideal gas, let's apply our hard sphere gas, which was PV minus B equals RT. Okay, so let's rewrite this as PV minus PB equals RT, or PV is RT plus PB. Okay, cool. So now when we apply this, we're going to say H1 equals H2, which is going to be U1 plus P1 V1 equals U2 plus P2 V2. Now, just like before, U1 is going to equal CV T1. And so we're going to have to do it for an ideal gas. And we're going to have to, so we'll do it for helium. We'll put in the actual values for helium and for nitrogen. Okay, so we're going to have, let's plug in also our ideal gas. So this is going to be, let's see, CVT1 plus RT1 plus P1B. Right, CV and B are material parameters that don't change. Is equal to CV T2 plus RT2 plus P2B. Okay, now CV plus R is simply CP, right? CP equals CV plus R. And so we can rewrite this as CP T1 plus P1B equals CP T2 plus P2B. So now let's get T2 equals, we're going to move this to this side, divide by CP. So we're going to get T1 equals, T1 plus P2. Let's actually have, I think it should be a minus sign. Minus P2 minus P1 B over CP. Maybe it's easier to see if it's P2 is T1 plus P1 minus P2 B over CP. Only one minus sign instead of two. Okay. So I was thinking of it like this because I can write delta T is minus delta P B, or C.B. Okay, so now in our demo, right, we had P1 was greater than P2, right? We had a pressure drop. We were doing expansion. If P1 is greater than P2, then this tells you P1 is greater, this is positive, then T2 is greater than T1. So we should only have warms. We should only get warming. So maybe what we'll do in class is we'll actually work out the numbers. So in class, work out the numbers for helium and nitrogen gas, giving you the numbers there, and see what you can even do it ahead of time at home and see how close we got to our demo values. But we already know that there's a problem. When we did our demo, the helium warmed, but the nitrogen cooled. And this says whenever we do expansion, we should get warms. Let's give it warms exclamation point. Right? So this explains helium, but not nitrogen. Okay? So next time we're going to go on, we're going to take and find another step in our non-ideality of our ideal gas, right? So we've gone from ideal gas now to a hard sphere gas. We're going to take one more step next time and see if we can explain that nitrogen cooling. Okay, see you next time, lecture 12.